Like so many ArcGIS users around the globe, I recently got back from our Esri User Conference in San Diego a couple of weeks ago. There were tons of really exciting updates and customer stories that were shared, but I just want to take a few minutes to cover some of the highlights that we showcased at the National Geospatial Symposium. We talked about using embeddings and AI to actually streamline workflows and do some more innovative things with disaster response and global data. So let's get into it. Specifically, I want to talk about this in the context of a hurricane response. We're going to use Hurricane Ian as an example. When Hurricane Ian made landfall in Florida in 2022, it became one of the costliest disasters in the state's history. I do want to acknowledge all of the incredible work that went into that emergency response. Having previously been in state emergency response myself, I know the incredible work that those people put in on the ground. Nothing I'm about to show is actually from the response in the sense of apps or the specific workflows. Just wanted to use this as a demonstration of what could be possible. And so we're specifically going to talk about geospatial embeddings, metadata, and AI. Here we're looking at an ArcGIS hub that allows us to share open data, whether that's inside of our organization to other organizations that might need access to secure data like our shelter locations or post-disaster imagery, or just being able to compile valuable information from the Living Atlas. So we're going to take some of the data from this open data hub and go to work. What we're looking at here in ArcGIS Pro is the Hurricane Ian track across Florida, as well as the max wind analysis as it impacted the coast. More specifically, I want to zoom in to one of these locations that it devastated the worst, and that is Pine Island. Pine Island was right in the track of the hurricane. And typically for an emergency response scenario, a damage assessment is extremely common as a first step. But if you're familiar with that workflow, it traditionally requires training a model, looking at images frame by frame, and even manually outlining a lot of where that damage is. But with ArcGIS Pro 3.7, there's a new embeddings toolbox that can make some workflows like this a little bit easier. Let's start with a little bit of level setting of what an embedding even is. So an embedding starts with something called a foundation model, which is an AI that has already looked at millions of different images without any training from us required. That model can then look at our imagery. And once it evaluates our imagery, it's going to create a grid. And across that grid, it'll assign values per tile that we can perform analysis and calculations on. Here, I'm actually using the Dino V2 foundation model, but there are 5 different foundation models that are available inside of the Living Atlas so that you can create your own geospatial embeddings, whether that's on imagery or vector data. Once we've run this tool, like I mentioned, it'll create a grid. And inside each of those tiles, there will be an embedding that allows us to interrogate our imagery further. Also available in this new embeddings toolbox is a Find Similar tool. Here we can add this new embedding layer that we just created, and I can zoom to an area where I have existing damage. I'm going to select that damaged area here, then zoom back to my entire area of interest. I can select Find Similar, and my map will immediately light up with all of the other tiles that demonstrate that damaged signature. So those same mathematical signatures that are inside of the embedding. This is really amazing to do with imagery because those embeddings are going to help you analyze quickly what is there. Is there damage on the ground? Where are households? Where are similar cars? Things like that. But often what makes these communities vulnerable to impact is not what's visible, and it's that information that lies a little bit deeper in the data and in our vector information. And that's where embeddings can also help. So we know that Pine Island was disproportionately affected by Hurricane Ian, specifically because of the demographic profile of the island. You can use these demographic profiles to create your own embeddings. And I want to show you what that looks like at a national scale. This is brand new to the Living Atlas, and these are the new USA Geodemographic embeddings. Basically, they're the entire country broken up into H3 hexbins, where each hexbin has an embedding that includes information like the American Community Survey or the Census Bureau demographic profiles for households, income, other information, business data, environmental information. And each of these hexbins is then visualized with these embeddings. Now, these don't mean a lot to maybe us, but they help our AI and our tools in ArcGIS Pro to be able to find these similar locations. So let's use these US geodemographic embeddings and see if we can find any other areas that might be similar to Pine Island and might be at risk for future hurricanes. So I'm going to clear out my previous search and selection and go over to a different tab. So here we can see all of those existing US geodemographic embeddings that I brought in directly from the Living Atlas. And here you can see that I've specifically highlighted an area where we had that high Pine Island damage. I can use that feature to see if there's any other areas across the Gulf that have that similar demographic signature that might be at risk in the future. So here I'm going to input my embeddings layer now as those US geodemographic embeddings. And instead, let's apply this to the entire Gulf Coast. Using that same Find Similar tool, it's now going to highlight my map with the other hexbins that share that demographic profile of Pine Island. You'll notice that some of these actually are well inland, so those demographic signatures might be a bit stronger than the geographic ones. One of the interesting trade-offs with embeddings is because we've put this into a really amazing format that AI and these tools can read, we've actually then maybe hidden some of that information from ourselves in terms of what exactly are we looking at in terms of the underlying demographic information of these areas. So I want to bring some of that back into the picture. And I can then export my result of all of these highlighted hexbins of my similar areas to Pine Island. Then, using some traditional GIS tools like Join, I can bring in my own authoritative data. Another option is I could use the Enrich tool in my geoprocessing analysis tools and input these exported Find Similar areas. Then I can choose from a variety of available variables across the ArcGIS system. Here I've created a pre-existing list of hurricane risk variables that I specifically would like to see in these particular areas. I can go ahead and add things like households that are below the poverty level, or maybe households that don't have a vehicle or do have someone with a disability or over the age of 65. Then I can run this tool and enrich those existing hexbins to see if there's any more helpful information that I can gather from these areas. I've already done that, and here I can then visualize all of the areas based on any of those pre-existing traits. back in my find similar, I'm going to go ahead and clear the results so we can see the results of my enrichment. So here we can see that ages over 65 in the household as a high population is likely one of those definite signatures that was found across all of these hex bins, although we'll see that there's a few outliers here. So this is all great for me, but maybe I want to actually be able to share this data into my ArcGIS Online organization so that other ArcGIS users or my leadership could access it. I've enriched this data, and I'm going to go ahead and share this directly to ArcGIS Online as a web layer. I've previously uploaded this, and then here we have our Pine Island Hurricane generate embeddings _ enrich. Whether this data is being used by a colleague or even an AI agent, which we're going to do in the future, we want to make sure that this data is findable and understandable, and that means whether for a machine or a human being. We can do that easier than ever using our new item details assistant. Here, my AI is actually going to take a look at all of the data that I have available in this feature layer, and then it's going to generate for me a title, a summary, a description, and even tags. So what was previously a pretty mundane task, I can now just look at quickly and make sure it's exactly what I'm looking for, and then save and update my entire layer here. This is really important because we are now in the age where AI agents do need to understand our data in plain language. And so these are really, really valuable tools for our analysts. But of course, what if we want these tools and even exploring these workflows to be available for people who might not be touching ArcGIS Pro at all? Well, let's talk about how we can bring AI into this workflow and make it powerful for everyone. One of the newer elements of our ArcGIS Maps SDK for JavaScript are our AI components. These work natively with your ArcGIS maps and data and include a number of out-of-the-box agents that'll help navigate your map and interact with queries relative to your data. But what's really powerful here is you can also create custom agents, like I did for this app, which is a demonstration of what could be for a Florida Hurricane Risk Explorer. So let's say that I'm an emergency manager and I really want to explore this data that my analyst has pushed up to ArcGIS Online to determine if there's anything that I should gather from the previous hurricane to make changes for my emergency plan or excavation routes for the next hurricane. So using plain language, I can interact directly with my assistant. For example, I know that I want to explore Sanibel Island and the demographic information of the population there compared to other places that might be at risk. I know that Sanibel Island was disproportionately impacted by Hurricane Ian due to its demographics and cutoff of access from the coast. Using a custom agent, I've developed that same find similar feature, but I can interact with it in plain language. So here, my analyst has already added those US geodemographic hex bins directly to my ArcGIS map, and I can ask it to find similar areas to that Sanibel Island profile. Like it did in ArcGIS Pro, it's going to highlight everywhere it identifies as a similar area. But this doesn't tell me a whole lot about the actual information about who lives there. So let's add some context and see if we can understand further. I've also created a custom agent that interacts directly with the Living Atlas. So now I can ask something like, let's add a risk index from the Living Atlas to see if there's any areas that have that similar profile but might be at a higher risk of further disaster. It's going to search for different risk indices, or for example here, this is just a precipitation index from the Living Atlas that it identifies as maybe relevant to my map. Let's tell it to add our National Risk Index directly to the map from the Living Atlas. Now I can see all of those areas that had a similar profile to Sanibel Island, but are also in some of these areas of much higher risk of further disaster. Again, because my earlier analyst did prepare my data with enrichment, I know that I can ask further questions about the demographic information here, something that isn't necessarily just available inside of the US Geodemographic embeddings themselves. Let's select these areas and then ask for it to tell me the demographics of the selected areas. The agent is now going to look underneath the data that's available inside of my map and summarize it for me, something that is so helpful in the short periods of time in which we need to be able to identify data, vulnerabilities, and similarities in the middle of a disaster. So here you can see it's summarized those demographic data information for me, telling me income and poverty, households and vehicles, connectivity, and then it's going to summarize the biggest differences specifically for hurricane vulnerability, getting me to answers way faster than I would be able to otherwise. And the greatest part about this is that I can embed an app like this directly into the hub that we started with so that my decision makers and executives and other analysts can access this with just the click of a button. Hopefully this was helpful and you've learned a little bit more about what these geospatial demographic embeddings are and how to use embeddings with imagery, the importance of metadata, and all that we can accomplish in the geospatial community and ArcGIS system with AI. This applies to more than just one storm, and hopefully this is something that your organization can take advantage of and share out in the future. So thanks for joining, and please reach out if you have any additional questions.